Get started in a minute. Yes, thank you for asking. Yeah. So it's 12:30. Okay, good afternoon. As you noticed last week, I needed to cancel our lecture on Wednesday. I apologize for that. It was under out of my control. So what I decided to do was to just reschedule the exam for Wednesday, and the lecture that I recorded for Wednesday last week is not going to be part of the first exam. It's just material that is going to be part of the second exam. But in order for us not to lose that teaching period, I decided to just go ahead and give a lecture on that particular topic. But we are not going to include that material on the exam. And today, what we're going to do is go over the instructions and the material that is going to be included in our first exam, which is scheduled on Wednesday, February 23rd. This is in 2 days. And the format of the exam is right here. We have 2 sections. In the first section, you have 10 multiple choice questions. And these are going to be questions that are more in terms of the concepts for the class. So we have covered, for example, different type of algorithms, different type of methods. You need to know things like what is the difference between an improvement algorithm and a construction algorithm. Those type of things are the ones that I test in these first 10 questions. So my advice in order to prepare for this first section is to go over the lecture slides. I have posted all of them. I also posted the ones with the notes. So you should have access to that material in the modules. So again, read through the slides, make sure that you understand the concepts, um, make sure that you understand when to use certain type of algorithms, what is the objective of that particular algorithm, if it is a construction type, if it is an improvement type. Um, in addition to that, we discussed the difference between product design, process design, schedule design. So you need to understand what are the differences. And that's part of the first lecture. And so on. So there are 3 main lectures. I split some of them in part 1, part 2, but you should go over those in order to get ready for those 10 multiple choice questions of the first part of the exam. Those are 2 points each. So it's a total of 20 points for the first part. Section 2 is 4 topical problems. Those could be short answer, explanation, description, and mathematical. So again, we have multiple labs for the first part of the semester. So my advice, again, go over those labs. Make sure that you understand how to solve those problems. In addition to that, you have the assignments. So go over the problems. The solutions should be posted and available for both the labs and the assignments. So you should go over those. And what I like to do, in addition to test you on the numbers, making sure that you know how to solve the problem, I can also ask you questions about the problem itself. So it's not just getting me a final answer in terms of the numbers, but I want to make sure that you understand what you're doing. So you should expect questions for this part in which you're going to be solving, right? But also, like we did for the formation of the cells, DCA algorithm, I can ask you to solve a problem, but then if you get into that decision-making process in terms of deciding how are you going to solve a conflict, you're going to have to tell me, okay, this is what I'm going to do, and this is how I'm going to split the cells, and I'm going to purchase a second machine, and I'm going to put one machine in one cell and one machine on the other cell. Or I'm going to be sharing that single machine. I'm going to put that in the middle, and I'm going to be creating 2 cells. So those are the type of questions that you should expect in addition to solving the problem. So section 2, 80 points. You'll get 20 points per question. Some of these questions are going to be easy. You're going to go through those in 5 minutes. At least one of those will take you more time. So you should be ready for the exam. You only have 1 hour and 20 minutes. Should be able to identify this question should take me a long time. This question should take me a few minutes, and then manage your time accordingly. Okay, if you don't, let's say you start with that long problem and you end up spending most of the time, and then you don't get time to get to the other 3 questions, that will go against you. So you need to understand the material, you need to make sure that you know how to solve these problems, so you can use the time wisely and complete the exam on time. I've been teaching this class for a long time. I have seen some cases in which students don't have enough time, but those are minimum. Okay, so make sure that you understand the material, make sure that you know how to work on these problems. If you try to solve and then you start guessing yourself, you're gonna be using more time than you need to solve those problems, and you might end up not having enough time. So any questions about the format of the exam? Yes.
Online, or
yeah, so the exam is going to be online. I was not able to secure a larger classroom. With COVID, we went through the experience of doing exams online, and I think for this class, it works. So we will be doing the exam online, at least the first one, see how that works for most of you. If we need to change that for the second one, I'll let you know. But for the first one, we're gonna do it online. again, and I will talk about that in a minute. The slides are already available, so you can pull them from Canvas if you like to. The lecture one, we talk about product process and schedule design. So again, as I mentioned, make sure that you understand the difference between product design, process design, schedule design, and facilities design. And understand also when to use each one of those. So there's a graph, a figure that we discuss in detail in class. It tells you if you have low volume and you have these other characteristics, you should go for product design, you should go for process design. So those things you need to understand. Flow and activity relationships. So we talk about flow system, material flow system, departmental planning, layout types based on material flow systems, and activity relationships. So again, make sure that you understand why we talk about these topics, what is relevant in respect to facilities planning, how this connect to what we are trying to achieve in terms of designing facilities. And then the last one, or the third lecture, was on layout planning models and design algorithms. So here we spend time talking about basic layout types, layout procedures, and algorithm approaches. So for numerical problems, we spend most of the time in terms of algorithms. We discuss the SLP, we discuss the graph-based method, we discuss the craft method, the craft algorithm. So you should know how to work with those. Those are problems that tend to take a lot of time. So I might ask you to complete one iteration, I might ask you to complete a part of the problem. I might present you with a solution and ask you to do something with that solution. So I can phrase the problem from different perspectives. But in general, if you understand how the algorithm works, what's the intention, how to go from one point to the next one, if you understand step by step how the algorithms work, you should have no problem. Okay, it's a matter of understanding what you're doing. The steps, if you have solved one of those problems by hand, then it should be fine. So those are the three topics or the three lectures that we cover for this first part of the exam, or for this first part of the semester. Now, in terms of the preparation, my advice is to go over this, the lecture slides. Those, again, are available. I have the videos also. So if you didn't get something from the slides, you can always go back and watch the videos. Labs and homeworks, so the assignments, have posted the solutions already. I provided if there's any formula or tables. I don't think we have tables in this particular exam. I'll provide those as part of the exam questions. The instructions, as I mentioned already, the exam will be available online, so you don't have to come to class to take the exam. You can do it from home. It will be online. However, if you don't have access or you don't have a space in which you can sit down and work on the exam, send me an email and I will find that space for you. Like, could be, we have multiple students. I can prepare this classroom. We have laptops. But I need to know how many of you need the accommodation. So if you want to work here in the classroom, just send me an email and I will do those accommodations. I'll bring the laptops for the students that need to have a computer, and you can work on the exam here. But just have to let me know before Wednesday so I can do those accommodations. The exam link will be available in Canvas. Okay, so it will show up as a notification. The exam will open at 12:30 on Wednesday, and then you have an hour and 30 minutes to complete the exam. What that means is, for the problems, you need to capture. I mean, you're going to be solving these problems on a piece of paper, so you need to secure some time to take a picture and upload the files, or to scan the paper and upload the files. So my advice is that you work with the exam for an hour and 20 minutes and then leave the last 10 minutes to do that process. So, so the exam will close at 2. So just keep that in mind. If you try to submit via email after that, you'll face problems with me. Okay, so unless you have like extreme circumstances that you have to show me some type of proof that you were unable to do that. Okay, but just make sure that you save that time. I'm not asking you for a scan. You can just take your phone, take a picture, upload the file. I'll take your question in a minute. The other thing is, for each question in the exam, you will have a space to upload the file for the question. So let's say problem 1, upload, problem 2, upload. You have a button to upload the file. If you prefer to put all the files together, let's say 4 problems in a single file, and then upload that file, that's fine with me. You just take that file, put it in one of the questions, and I'll get to it. Okay? You have a question? That was a question? Yes. So yeah, I assume that. So that's the way I'll handle it. Okay, so it depends on if you have enough time and you want to go through the process of upload single files, then that's fine. If you have less time, you just want to upload one single file, you can do that. So the exam is closed book and notes, so I will remove everything from the Canvas site. The link to access the exam will be available in the Canvas modules. So when you go in on Wednesday, you'll see a single module there. It's going to be for Wednesday. The rest of the things will be unavailable. Clearly show your work and all formulas using your solution. This will help me work on partial credit. So for example, if you're working on a problem like this one, in which you had to use the direct clustering algorithm to solve this problem, you will have one of these in the exam. If you just show me the final answer, that's going to be incorrect. Okay? Just want you to be aware of that. I'm recording this lecture. You get a 0. Okay? So make sure that you show me the process. Okay? Show me, I mean, you don't have to show every single detail, but you show me the summation for the rows and the columns. You can show me the sorting, and then you can show me another table in which you show me the final answer. But I need to know this. You need to show me the steps. This final answer by itself is a 0. Same thing applies for the other problems. So clearly show your work and formulas using your solution. If you end up with the wrong answer, if you show me your work, then I can provide you with partial credit. Okay, with no work, final answer is incorrect, then there's nothing I can do. But if you show me what you did, and at the end you got the wrong answer, you will get partial credit. The multiple choice true or false questions, you will answer using the computer. So just click the right answer. For the 4 question problems, you're gonna upload a file. So work the solution in paper, take a picture, scan, and upload your solution file. You will have 10 minutes to upload the files. So that's minimum. The minimum recommended is those 10 minutes. Start working the exam at 1:50, use the time after that, 1:50 to 2 to upload the files. The exam will close at 2. So you will not get a flag, you will not get a reminder to do this. The exam will just close at 2. Okay, so you have to keep in mind that you have to keep some time to upload these files. Any questions? So again, my experience after COVID or during COVID is that students might think that online exam will be easier to handle, might be easier in terms of getting a better grade. It could be if you prepare. Okay, if you don't prepare, then my experience is that students end up having lower scores in this type of exam because you're going against the time. You are not in a specific environment in which you can concentrate. So this requires some preparation from your part. And again, if you feel that you don't have that space in which you can sit down and work on the exam, email me, let me know, send me an email, and I will provide those accommodations for you. I have done it before. I'll just come here, put a computer in front of you, and you can work on the exam and then leave. Questions? Yes. Yes, so I will be available via Zoom. But I will not be looking at all of you via Zoom. You see what I'm saying? Like if you have questions, yes, I'll be there for answering those questions. Yes.
If you have us do the start question, then I'll start one.
Yes, that's a very good question. Yes, so for those questions that you were not required to submit, yeah, I will go over those too and make sure that you know how to solve those problems. Yes. Yes, yes. All the problems, the solution for all the problems are available. Yes. Okay, so what I decided to do is to show some problems that might be similar to what you're going to be seeing in the exam. So we talk about this computation of the input required based on an operation in which you have a rework. In this case, you have rework and you have parts that fail in inspection upon completion of operation 2. And then you need to compute how many units must be processed, start with in order to meet the required output. So this problem, difference between this one and the, well, the challenge about this one is that we have a rework station, right? So for us to be able to determine this input, which is what we want to find, we need to take into account this rework. So what that station is doing is taking some of the defectives from station 2, is reworking those, and then those that are fixed are going back into the process. So the question is, how many units must be processed start with in order to meet the required output of 5,000 units? So the information that you have available in this problem is just the output required, and then you have the percentage of defectives for each station. And based on that, we want to know what is the required input. So I solved this, I show you the solution that is posted online, but after looking at the solution, I was like, well, maybe we need some extra guidelines here in order to get to these equations. So that's why I decided to present this problem as part of the review. So the idea for us is to work on this problem. Typically, we go backwards and trying to get the information for the last station, and then work the previous one until we get to the first one, which is inspection station 1 in this case. But for this problem, there's not necessarily a backward only process that is taking place. We are also building from the input and from the output at the same time, because we have to create these equations that will help us solve this problem. But we know some information. We know that input here, the amount that is going to flow in this direction is the input times the defects percentage, and then the output of 1 is equal to the input of 1 times 1 minus D1. And that's based on this conservation of flow, right? So the amount of defectives, and then what's moving forward is the complement, which is this I1 times 1 minus D1. In the same way, we know that the output of 1 is going to be equal to the input of 2, right? Because this amount is what's going to enter this station. So we know that this output is going to be equal to the input of this station. So, and we know that the output of 2 is going to be equal to the input of 2 times 1 minus D2. Same thing that we did here, right? Output of 1 equals 1 minus D1, 1. I1 times 1 minus D1. We're doing the same thing here with the difference that I2 equals 1 minus D2. So, so for example, if I want to generate an expression here that doesn't take into account, remember that at the end, what I want to obtain is an expression in terms of I1, right? Because that's the unknown that I'm trying to solve for. So everything that I'm going to be working on as part of solving this problem is trying to create an expression that is in terms of I1 and D1, D2, D3, and D4, which are the things that I know. And O3. I know O3, this O3. So my knowns are this, 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 and this. I want to create an expression that takes that information into account and solve for I1, because that's the unknown. And these equations right here are trying to do that, exactly that. So let me work through this. So as I show you already, O2 equals I2 times 1 minus D2. Right, so that's right here. O2 equals this. But I know that the output of 1 equals the input of 2. Right? So I can substitute O1 into I2. And I know what O1 is. I know O1 equals I1 times 1 minus D1. Right? I know that expression. So I can substitute this O1 into I2 and create a new expression that is in terms of I1, which is the unknown, so this is 1. So now my O2 no longer having this I2 unknown, right? I don't have that information. My expression for O2 is now in terms of D1, D2, which I know, and the I1, which is the unknown that I'm trying to solve for. Okay, so I got an expression in terms of the knowns and also the unknown that I'm searching for. So that's for O2. I4, I know that the input of 4 is gonna be equal to I2 D2, right? Because the input of 4 is the defectives from station 2, and the defectives from station 2 are equal to I2 times D2. So I can find I4 in terms of that expression. However, since I know that I2 equals O1, I can use that same substitution to generate an expression for I4. So I4 equals I2 times D2. And I know that O1 equals I2. So I can substitute this into here. And that equals the following. I4 equals I1 times 1D1 times D2. So again, I'm creating all these expressions for O2, I4. You can see the similarities between the expression. All of them are in terms of I1 and the defective rates. And that's what I want. I want to create these expressions in terms of I1 because I1 is the unknown that I'm searching for. And the rest of the expression is in terms of the knowns. So I have I4 now. O4 is equal to I4 times 1 minus D4. Right? So I know O4 equals I4 times 1 minus D4. And I know that I4 is this. Right? So I can substitute into here. And I'll get an expression in terms of I1 and the knowns. So this is I1, 1 minus D1, D2 times 1 minus D4. And this is O4. So you see O2 is in terms of I1, I4 is in terms of I1, O4 is in terms of I1. Next, so now I need to find I3. And what is I3? I3 is the summation of O2 plus O4. Because those two are going to connect into station 3. So if you sum O2 and O4, you find input of 3. So the input of 3 is going to be equal to O2 plus O4. I know O2 is right here, right? And I solved for O2 already. And I know O4, so I just have to combine those two. Let me use a different color. So this is O2, this is O4, and I'm going to be adding those two. So this equals I1 times 1 minus D1 times 1 minus D2 plus I1 times 1 minus D1 times D2 times 1 minus D4, and that's going to be I3. Okay, so I got I3, and I'm getting to the last piece, which is O3. And O3 is equal to I3 times 1 minus D3. Right, so we know that this O3 equals I3 times 1 minus D3. And I know I3 already. I know I3. I solved for that. This is I3. So I need to substitute all that. O3 equals I1 times 1 minus D1 times 1 minus D2 plus I1 times 1 minus D1 times D2 times 1 minus D4. All that multiplied by 1 minus D3. And as you can see now, I have an expression in terms of the unknown, which is I1, and the rest of the information I know. I know D1, D2, D3, and D4, and I know O3. O3 is 5,000. So I can solve for I1. I1 is going to be equal to, I have to take this out, right? I have to do some math here. I1, 1 minus D1, 1 minus D2, plus 1 minus D1, D2, 1 minus D4, and all that D3. So O3 equals this, and then I1 is going to be equal to O3 divided by all this. 1 minus D1, 1 minus D2, plus 1 minus D1, D2, 1 minus D4, and multiplied by 1 minus D3. So this is the final expression. I got the equation in terms of I1, which is the unknown, and I know O3 is 5,000, and I know D1, D2, D3, D4. So if I substitute all those numbers, I'll get I1 equals 5,854. So all that process to get to that equation. That equation, which is in terms of the known information. Remember, the known information is the parameters D1, D2, D3, and D4, and parameter O3, which is 5,000. If I create an expression in terms of those known variables, then I can get the unknown, which is I1. Okay, so that's why I went through the process of creating the expression for O2, I4, I3, all those expressions are in terms of I1, because I1 is the unknown, and that's what I'm searching for. So as you can see, this is a type of problem that will take you 15, 20 minutes to get the answer. Okay, so if you see something like this in the exam, you know that you have to separate some amount of time to work on this. Okay. And this is not something that you will be able to do if you haven't practiced. You need to understand what's going on. So that's why I wanted to show this problem and how you go about it. Questions? Yes. This one? This one? Oh, yeah. So what I did was I took I1 out. You see here is I1 times this plus I1 times this. So what I did, I took I1 out and then multiplied by this and this. So basically, I factor this out, make it a I1 out, and then multiply by this. And the 1 minus D. Minus D3 is outside. It's outside those parentheses.
Okay. Yeah, okay, I see.
Yeah. Should be here. Yeah. Okay. Good question. Okay. So the rest of the problems I think are more straightforward. We did a lot of practice on this. So this is on similar to what we just did, but in this problem, we don't have a rework station. So the difference between this problem and the previous one is that in here, you needed to compute not just for a single input, but for multiple inputs. You needed to tell me how many units you needed. So for part type A, part type B, part type C. And this problem has no rework. So in this one, it has something like this, M1, M2, M3, assembly 4, assembly 6, and then machine 5. So here. So this was the process, and we needed to find this input 1, this input 3, and this input 5, which were corresponding to part type A, part type B, part type C. But I mean, this one is be easier to solve because you don't have to deal with the rework. The only challenge about this particular problem is that you have to compute the input for different sources, from different sources. I mean, yes, go ahead. The rounding. Okay, that's a very good question. And if you lose points because of rounding, you can email me and I can check on that. So I will, the recommended, like for this particular case, you will round at the end of the computation, right? So you carry on with your numbers, and then once you get the final answer, that's where you round. Okay, so you will round up, obviously, because 0.3 will mean that you need an additional part to complete the requirements. Good question. And again, if any of you lose any points due to a rounding error, email me and I can check on that. I don't grade the assignments, but I'll be grading the exams. Okay, so I'll be looking at that on my own. So questions? Good. So moving forward, we have this direct clustering algorithm. Here we have data for local wood manufacturing, was to decrease the material handling by changing from a process layout to a GT layout. It's considering installing a conveyor for intracellular movement of parts. It wishes to restrict intracellular movement. The machine part matrix for the wood manufacturer is shown below. Use the direct clustering algorithm to form the cells. If conflict exists, propose alternative approaches for resolving the conflict. So when you look at these problems, like you did in the assignment, the exam, remember to read the whole thing. Like that last part is saying propose alternative approaches for resolving conflicts. That means that you have to tell me what you will do. Okay, if you just tell me the answer, numerical answer, and you don't state how you will solve those conflicts, then you will lose some points. So write down, this is what I will do. So here we have the machine part matrix. So remember, first thing you do, you add the totals for the rows and the columns, and that's what you're observing here. From there, you're gonna do the sorting. So I show in this second part, this part, I'm sorting for the rows first. So we go in this non-decreasing or decreasing order, and then I sort for the columns. So that's what we are seeing here. So you see a total of 2, 2, 2, 2, 3, and 3. I'm sorry, this is 4. Apologize. Yes. And then once you get the sorting done, you're done with step 1. Step 2 is to look at the columns, go row by row, and you see if there's any opportunities to move towards the left. So that's what you're observing here. We're doing that movement towards the left. So we move 3 first, and then 6. 4 stays, 2 follows, then 5 and 1. Okay, so we move the columns towards the left based on the number of ones that they have in the first row. Once you're done with row 1, you move to row 2. The columns that were already moved, those are fixed. When you move to row 2, you are not going to move. For example, here we move in the first row, we move 3 and 6. So 3 and 6 are fixed. When you move to the second row, which you're looking at ones in the second row, you're going to move 4, but you don't move 4 in front of 3 and 6. You don't do that because 3 and 6 were moved before that, so those are fixed. So 4 will go after 6, and then 2 will go after 4. And you move to row 3. You check on row 3. You have column 5 that has a 1, so 5 goes after that, and then after that 1 is the one remainder, so you keep 1 at the end. And then once you're done with step 2, which is the movement of columns, you go now and do step 3, which is moving rows up according to the ones per column. So you'll see here, you will move 3 first, right? So you go column by column. This one has a 1. Then you check there's no 1s. Here's a 1. So 3 will move after 8. That's what you see in here. You don't have any other 1s in column 1. So now you move to column 2. You have 6. So 6 will go after 3. And then you have 1. So 1 is going to go after 6. And you continue that process until you have completed all the possible moves upwards into the matrix. For this case, we end up having a conflict. So that's for machine 5. So how do you solve that conflict? You need to, actually, there's no conflict here. You can split this clearly because machine 1 is only used by the cell at the top. So in this case, there's no need for splitting the cells. You have 2 clear cuts here. The ones in yellow and the ones in orange. Yes. I mean, the important thing here is that I see what you're trying to say. Like, if you move it, it will be clear that, but that's not a step of the algorithm. What we're seeing here is the actual final solution of the algorithm. So based on that solution, you had to look at the configuration. I understand what you're saying. If you bring it here, it's going to be clear that you have all them grouped. You don't have to do that. You just have to focus on the actual solution and see how can you split the cells. No, I mean, once you show me this, I know that you got the final matrix. So everything you do after that is just helping you figure out the appropriate split. Yeah. Yes. It's two cells because if you see here, even though this part is separated from this one, this machine is used by these two parts that are only part of this cell. This machine is not used by this cell. Yes, if it was, then there's a conflict. You have to come up with a way to split those. Good questions. And then this is the problem for this latest assignment. This is a craft problem. So you have manufacturing, concern has 5 departments labeled A through E, located in a rectangular building shown below. And in this problem, suppose that the flow data, the unit cost data, and the distance matrix are given as follows. So in this problem, you remember we started by looking at the centroids and computing the distances. In this problem, I already gave you the distances, so you don't have to go through that process. The distances are listed in the third table, distance matrix. So you have the distances, you have the unit cost, and you have the flow between the areas. So there's 2 questions here. If you look at the first question, using Craft two-way exchange procedure, indicate all department pairs Craft will consider exchanging in the above layout. So to answer this question, you need to remember that you're only allowed to do these two-way exchanges for those departments that are sharing a wall, and also those departments that have the same area. Even though they are not next to each other, if they have the same area, you can do the two-way exchange. So the question is asking all the possible two-way exchanges that you can do. So this is a concept question, right? When I go back to the first few slides of the review, I'm not asking you to solve anything. I'm just telling you, tell me what are the possible two-way exchanges that you can do. So to make things simple, first thing you can do is to check on the areas. We have 5 departments here. You can compute the area for those departments and then see if there's any of them that have the same area. In this case, we have B and D. Even though they don't have the same shape, they have the same area. They are not located next to each other, but they have the same area. So they can be considered for a two-way exchange. Okay. And then once you get the areas and you confirm if there's possible two-way exchange for those that have the same area, then the next thing is to check on list those that are next to each other. So for example, you know that these 2 are next to each other, these 2 are next to each other, so those are 2 possible two-way. So we have A and B, and we have B and C. Then we have A and E, right? So A and E, and we have E and C, and we have E and D. So those are the possible exchanges that are based on departments that are sharing a wall. And then you have B and D that even though they are not next to each other, they have the same area. So you have to list them also. And those are all possible two-way exchanges that you can do. Yes.
I thought the first step of the algorithm was to create a reward chart that multiplied like the cells, I think different types together. Because the algorithm really wouldn't consider moving two departments if it's no value added.
Yes, so we haven't got to that part yet. The first question is just asking whether or not you can consider two-way exchanges based on the current information that you have on the layout. We haven't solved the problem yet. Okay, so yes, the question is, in order for us to make sure that we want to do an exchange, we need to have some type of benchmark, right? In terms of the performance of the current layout. We don't have that yet. That's correct. But we have to compute that in order to see if there's a potential benefit of making any of these exchanges. So we move to the next one. So the first, any questions about the first part, possible exchanges? No? No? So the question next to us is compute the estimated cost of exchanging departments A and E. So again, for the purpose of the exam, for you to solve these type of problems, I cannot ask you to go through the entire iteration because it will take you the entire hour. So these type of problems are designed for you to show me that you know how this works. So the problem now is asking, compute the estimated cost of exchanging departments A and E. Okay, so assuming that you are going through the first iteration, what will be the cost associated with changing these two departments? Okay, so what you will do now is check on the updated distances. So basically what this is saying is you are going to switch A and E. So this will be E now, and this will be A. And it's asking, okay, if that's the case, what will be the estimated cost of the layout based on that change? So if you have all this information, the flow, the unit cost, and the distance matrix. So we have for A and C, it's 5 for A and E, it's 5 for B and C, it's 6 for B and D, is 2, C and D is 3, and D and E is 7. Okay, and that's all coming from here. We have the flow. We also have the cost, right? And that's coming from here, A and C, A and E, B and C, B and D, C and D, and D and E. So question now is, and these are the original distances, right? So depending on, so all this information, first 3 columns are based on the original layout. But now if you remember from our discussion, when you make these swaps, you're going to assume that the distances are not changing. You're assuming that the swap is keeping the centroids in the same place, okay? So the distances that belong to, in this case, E are going to be now the ones that are from A, and the ones from A are the ones that used to be from E. So what that means is A and C since A is now moving from the original location to the location of E, the distance from A and C is now going to be the distance. We're changing A and E, the distance from EC. So EC distance is 8. So that's what we have here. Distance from AE is not going to change because they are just swapping positions. So distance from AE is going to be AE, is the same distance. BC is not affected. BD is not affected. CD is not affected. DE. Now the distance is going to be the distance from D to A. So the distance from D to A is 80. Okay, so swapping is updating the distance. Now we want to compute because the question is compute the estimated cost of exchanging departments A and E. So the total cost is the multiplication of the flow times the cost times the distances, right? So for this is the summation for all I's and J's of Fij times Cij times distances Ij for the swap. And that means that I will take the flow here. Oops. This times this times this plus 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 this times this times this. So that will be equal to pi times 1 times 8 plus pi times 1 times 11 plus 6 times 1 times 12 plus 2 times 4 times 22 plus 3 times 3 times 10, 7 times 1, oops. Seven times 1 times 18, and that cost is 559 units, which is what you have here. So the problem on this algorithm craft could be something similar to this, in which I'm going to tell you, okay, this is the information. Tell me what would you do given this information? What would happen if you swap these two departments? I can actually tell you, I'm considering swapping these two. Is that something that is allowed by the algorithm? You can tell me yes, no, why not? So I can create different type of questions my plan is, or my objective is to make sure that you understand how this works. Yes. For the first question, is that what you're referring to, or?
No, I mean, I know that the first question is the border,
Yes.
but after doing the calculations.
Oh, yes. So what you would do, if you were doing the entire algorithm, you first gonna compute this that I just did for the current algorithm. So you're gonna get that benchmark, right? So this is the cost of the current algorithm. And then you will you want to identify the possible exchanges. So in this case, there's 1, 2, 3, 4, 5, 6 possible exchanges, and you have to do each one of them. You have to do the swap for each one of them and compute this for that new layout. Like, let's say you do A and B, you swap A and B, then you update the distances and you compute the performance. And then you go to the next one, A and E. You update the distances, you compute the performance. And you do that for all of them. And then what you're gonna do is, based on the cost, you're gonna say, okay, there's one that is better or not, based on you're gonna look for the minimum. So if you find one that is cheaper than the current one, then that's the one that you're gonna select, right? And then you're gonna update the centroids, and you go through the process one more time, and you keep doing that until you find no improvement. Okay, yes. We have cost. Yes, the cost is in dollars, you're right. So this should be dollars. Yes. This is, yes, for this one, yes. No, I'm not doing, for the problem, I'm not doing all of them. I just ask you to do one and tell me what the cost is. Okay? Any other question? Good. So I think that's the last problem. Now, if you have any other questions, I can answer those. Yes. Which one? Assignment 3. Okay. Oops, sorry. Let me open the PDF. So 28. This one?
Yes. It's like, in this part, we're just calculations. It looks like it just takes into account like the diamond chart.
Oh, yes, yes. Yes, this one. Yes, this one isn't relevant. Yeah. We don't use this. Yeah. Yeah, I apologize for that. I got that question from. Yeah. Yeah, I apologize for that. So for this problem, yeah, this information is not relevant. I pulled this problem straight from the book. And yeah, I copied the entire information that was provided for the problem. But you solve the problem using, yeah.
I was trying to figure out how to integrate that. So,
If you solve it using this part, I mean, you can still work with this. You just have to, yeah, they're not consistent. Yeah. if you got it wrong, just send me an email and I can, yeah, work with you. Yes, sir.
Thank you.
No problem. Any other question? Not, then I'll talk to you, or I'll wait for your answer in terms of needing space to do the exam. If not, then the exam is gonna be available online. If you have questions, I have office hours this afternoon. And if you need to talk to me tomorrow, send me an email. I can schedule some time to talk to you as well.
Is it? Was class time?
Schedule.